Hello, this is Clayton Balmas, and I'm your teacher here today in our audio classroom here with SynMax University, available at synmaxperformancelubricants.com. Today, in our session, we're going to be talking about the extreme heat condition endurance test for the transmission and rear axle. So there's going to be some wonderful information that we want to share, and hope you enjoy our time together as much as I enjoy sharing with you. So let's go for a ride and see where it'll take us. A private testing firm was asked to providing a solution for transmission rear axle endurance, durability, performance testing under extreme heat temperatures found within the Grand Am type endurance conditions, found in like 120 degrees in Arizona, Nevada. Now there was two equally prepared cars with temperature telemetry sensors, and they ran at the same time in the same conditions. Both days had equal temperatures of about 115 degrees in the afternoon. So we were very close to the 120, and we were trying to get up to a maximum speed of 175 miles an hour. Now, what would happen was the transmission could not exceed 300 degrees Fahrenheit nor the reaxle, or 280 for the main. Okay. The testing requirements was that we wanted to have an open throttle test, 15 minutes of just preconditioned testing at 85 miles an hour to stabilize component temperatures. Then we'd nail it and accelerate to the maximum speed at 155 in the circle track or the oval. Hold for 30 minutes. Then we'd have a 15-minute like road course section, and then 30 minutes of soak. Now we had to stay between 38 and 49 centigrade, or 100 and 120 degrees Fahrenheit. So we were like at about 115. We had problems creating, having an increased drivetrain temperatures. You see, with a GT production specification to achieve and maintain aero and mechanical grip stabilization at the continued high speeds of 155 miles an hour, it required advanced aerodynamic package, which was then placed in the lower front and edges of the car to reduce and control the underflow car turbulence, to give it like what we call like a sucking effect to the ground. This reduction of undercar airflow caused very high temperatures, which was above the corporate GT specifications, basically because the undercar airflow is normally used to keep the drivetrain cool by air passing over and around the transmission and rear axle case housing, and it would naturally transfer the heat from the outer case to the air. Because of this, the transmission rear axle were exceeding the set corporate GT production temperature limits at the maximum speed test of 155 miles an hour at the ambient temperature above the 110 degree Fahrenheit. The temperature limits were exceeded in a climate chamber and then during the track testing. The next step after the failures were taking place at the higher temperatures was that there was a requirement for a lubricant that would allow a higher operating temperature of the components. SynMax Performance Lubricants supplied such a fluid capable of operation at 320 degrees Fahrenheit for extended periods. Then a series of 10 maximum tests were performed with no failures reported. You're going to see the information and data from that. The transmission and rear axle were then sent back to the suppliers for evaluation. The rear axle supplier reported no problems with either the bearings or the ring and pinion, and the transmission supplier reported no bearing or gear problems at the sustained high temperatures. But there was the composite cages holding the bearings are showing signs of thermal fatigue and wear, and it was recommended that a cooler would be installed. So it was decided to install the cooler for safety margin. But in this test, I'm about to share with you some of the confidential information that this engineering firm was able to provide. Now, the manual transmission and gear lube products that were tested, we had two cars. One was a baseline of current corporate approved, what we call original equipment products, which would be like a mobile standard type manual transmission fluid, which was equal to like a Mercon 5 ATF. And then the gear lube was like a synthetic 75 and 40 because their theory was heavier was better. SynMax provided a different theory, which was by using aerospace level gear lubes and differential oils. And the differential oil was a true high poi gear lube, an SAE 90, a pure synthetic. And then we had the diamond-like additives in both. Now here was the transmission maximum test. You see at the 15 minutes of preconditioned at 85 miles an hour to establish the component conditions. Then we accelerate to the maximum competition speed allowed, which was the 155 hold for 30 minutes. And then we'd have a 15-minute road course and then a sign off on to see what it would do. Now, the OE base fluid, which was like almost like your transmission fluid, at 85 miles an hour at minute 5, all right, it was already up to 212 degrees, and then at minute 15 it was at 226. The SynMax MTL70 at minute 5 was at 145, and then at minute 15, now this is at 120 degrees temperature, okay, or 115 that we had, was at 194. So it was running a lot cooler, okay. Then when it was at full acceleration at 155 miles an hour, at 10 minutes in to the full Vmax, which would have been 25 minutes, the temperature way exceeded to 340 degrees Fahrenheit, which was the abort sign-off time. The SynMax at 155 miles an hour, 18 minutes into the test at minute 43, then went to the abort failure. So it took twice as long to do it. You might say, Clayton, but it still failed. Well, yeah, that's because it was pretty hot in there because there was no place for the oil to transfer the heat. So the transmissions were taken apart and evaluated. And as we shared before, with the SynMax, it still looked like new. And but they had to put a cooler in. So after they put the cooler in to be able to have sustained temperatures, let me tell you what happened. It was amazing. At 85 miles an hour, okay, at minute 15, it was at 180 degrees, so it saved 14 degrees. At full throttle, at 155 miles an hour, at 115 degrees temperature, it was only at 216, so it passed. And then even on the hot idle test in the soak, it didn't get past 280, so it passed. So it was really good. So the fluid did its job. Now on the rear axle, this was a 373 gear because this was a GT production car. We had about the same temperature sign-off, but it was a little less. In the differential, we had to have a sign-off of an abort failure at 293 degrees Fahrenheit. So here's what it did. At 85 miles an hour, at minute 5, okay, the differential was at 221 degrees. At minute 15, it was at 239 degrees. The SynMax at 85 miles an hour at minute 5 was at 203, and then at minute 15 was at 221. So if you want to know what your late model would be doing, which is, the average speed of about 85 miles an hour and 115 degrees temperature, there you go, 221. Now at full Vmax or 155 miles an hour, 11 minutes in, at minute 26, the OE base fluid was already at 311 degrees. The SynMax Super 90 at 155 miles an hour, 18 minutes into the test, almost twice as long, minute 43, it raised to 304. So it took twice as long for it to get to the abort failure. The axles were taken apart, and even at extreme temperatures of the 300 degrees, the components still look like new with no metal fatigue. but they couldn't, the seals and everything. You couldn't sustain that. So then cooling was required, heat exchangers. And then in the test, all right, at 85 miles an hour at minute 15, it was at 194 degrees. All right, so the heat exchanger cooled it off about 25, 26 degrees. At full Vmax at 155 miles an hour, it it passed. It didn't get above 268, and that was about the abort failure was at 293. And then even in the hot idle test, it didn't get above 250. So that's a good thing. So Aeromotive Research took this information from the engineering group, and basically it was able to sustain temperatures at a lower, sustain high performance at a lower temperature. Even at 85 miles an hour, it was like 20 degrees cooler. And to get to the abort failure, it almost took twice as long to get to that point. Why was that? Because surface technology with the diamond-like additives and aerospace base oil that was able to transfer the heat, and that is just truly amazing. Now, if you have a race, I just got to say something. If you do have a racing condition and you don't have a Detroit locker, and you've got what we call a diamond tract, or what I call 3 egg beaters in a bowl, you really need to go to the 75 140. Okay, but in a production car with a standard um, uh, positive traction with clutches, you can do the 90 weight. So that's the presentation end. Um, we want to thank those that were involved, and the thermal system specialists at the engineering group in Michigan that conducted this test. They have our deepest appreciation, and it shows it works. All right. So if you want the aerospace advantage uh, for the automotive industry, SynMax is able to provide that. So this is Clayton Balmas here with SynMax University at synmaxperformancelubricants.com, and we want to thank you for the time that we had together. Bye now. For technical test and brochure information on how the aerospace advantage for motorsports can work for your race team or commercial needs, go to synmaxperformancelubricants.com.